we take a look here at number 7, we've got lithium potentially trying to kick out tin. So let's take a look at lithium versus tin. Lithium is at the top, tin is at the bottom, so lithium is definitely stronger. So that means tin is now going to be by itself, and lithium is now going to be with nitrate. So we're going to call that lithium nitrate. All right, now that we finished that word equation, we can start writing out some notes. Lithium by itself is going to be Li. It says tin with the Roman numeral 2, so that means tin is going to have a 2+ charge. And nitrate, when you look on the ionic compound sheet, has a -1 charge overall. Now, tin by itself is just going to be Sn because there's no charge on objects that are by themselves. But lithium and nitrate form an ionic compound, so lithium has a 1+ charge. You can see that right here. And nitrate, as we already figured out from earlier, has a 1- charge. Now that we have that, let's put these guys together. Lithium is going to react with tin nitrate. Tin is +2, nitrate's -1, so you're really going to need another nitrate to balance that out. So with 1 tin, I'm going to need 2 nitrates. So I'm going to put nitrate in parentheses and put a 2 on the outside. Now that I have that, I'm going to draw my arrow. I'm going to have to put it diagonal a little bit since I ran out of room. In fact, excuse me, I'll erase this really quick to make some space. But we've got tin by itself and then lithium nitrate. If you remember before I erased it, lithium was +1, nitrate was -1. So that becomes LiNO3, lithium nitrate. Now that we have that, we can balance this out. So you've got 2 whole nitrates over here, so I'm going to need to put a 2 here to make 2 nitrates. That's also going to go to the lithium, Li. So I'm going to put a 2 there for 2 lithium. Now that we have that, let's just double check everybody. We've got 2 lithium, 2 lithium, 2 nitrates, 2 nitrates, 2 tins, 2 tins. I'm all balanced with a 2, 1, 1, 2 for a ratio. All right. Way to go. Let's look at the last one, number 8. Sodium is going to react with lead-2 sulfate. So sodium is going to come in and potentially kick out lead. Let's take a look at where sodium is, right here, and lead is down here. So sodium is higher up, so that means sodium is stronger. So that means lead will get kicked out and be by itself on the product side, and sodium and sulfate will come together. So I'm going to call that sodium sulfate. All right, let's do some of our work. Sodium's all alone, so off the periodic table, we just call sodium Na. Lead-2, notice it says lead-2. Lead symbol is Pb. It has a 2+ charge. Sulfate, if you look on the ion sheet, has a 2- charge. All right, lead over here by itself is just Pb. There's no charge on it. And if you look, sodium here is in a compound, so sodium has a +1 charge overall. We see that too on the chart right here. And then sulfate, according to the ionic compound ion sheet, is a 2-. So now we've got all that. Let's put all this together. I'm going to thicken up my pen a little bit. Here we go. Sodium's Na. Lead-2 and sulfate make PbSO4. Now that we have our arrow, let's write out lead by itself. Lead by itself is just Pb. And when we have sodium and sulfate, it looks like we're going to need 2 of these +1 sodiums to cancel out with the sulfate. So I'm going to do Na2SO4. Now that I've written out the skeleton equation, I just need to make sure things balance out. It looks like the only thing different are the sodiums. There's only 1 sulfate, there's only 1 lead, but in the end there's 2 sodiums, so I need to put a 2 there. So 2, 1, 1, 1, and that'll balance everything out. All right, that finishes up single replacement reactions. Let me know if you need anything else. Happy to help.